And so we're gonna look at the up down counter now to see if it can go up and down. So this one is supposed to go up and down. Ready?
Yes, sir.
Yeah, Andre, come back yet. Them not come back yet.
No, they don't come back.
I'm gonna say Nathaniel. My name Daniel. Daniel always busy. I'm click out this and click back down. UD enable. All right, no changes. No change.
Okay. Everything full out.
Wait to do shift to what? Left or right?
It's look like a left. Do I look like it a skip tool?
Okay, it's a cycle.
Or
Yeah,
side?
circle. It's going in a circle.
Okay.
Up down. All right. We can do this 1-0
Go to the right now.
and 1-1.
Everything look like the same thing.
Same
Except that
thing.
it's cycle.
Yeah. All right. Look at the real thing now, the real McCoy.
Yeah.
They call one of the real McCoy.
Counter.
All right. That one now. So we're gonna know this one have 2 now, don't it? Hexadecimal, but it's 2. So binary down here and the hexadecimal down here. Which number hexadecimal start off with? What's the first number in the hexadecimal?
0, sir.
0. All right. Go through 0, 1F. But it is going straight hexadecimal. Let us skip everything and go so far up now. Because it is going above it now, it is going above. It can go above the 15. You understand?
Yes, sir.
How much is supposed to go down to? It's a down
Right
counter, you
back.
know.
Right up to 0.
Yeah, because it's a down counter. It is. It. I go right up to that. All right. Look at another one. Another one that is like an up down counter. All right. Here's an up down one. But this one does have this alone. So I want to use one of them. It's a one-shot timer. Rescaler. We're gonna look at these next class. I'm gonna look at this as well, like the DA, digital to analog and analog to digital. And we're gonna look more in detail on this analog to digital and digital to analog. And then we get down to this now, the mini CPU with the ALU and everything in it. All right, with the sequencer. And then we're gonna animate this one. We're gonna look at it to see what takes place with all the registry and so forth. So we're gonna do now, we're gonna look at some information with the registry now. Mhm. Look at some information with the registry. All right. 4-bit register. Probably load, not this one. We need to go way back. Registers. Right. Everybody all know? All right, registers. So what do we say registers are again?
Store information. Store bits.
All right. How long is stored information for? And is it slow? Is it fast? Does it hold information permanently or temporarily?
Depends on the type of storage.
It, so a register store information temporarily.
Temporary.
And when it store it, what does it do with it? What do with the information? All right. Let's say you write a program, and when you write the program, you know that you have variables and data type. If you declare a variable, like for instance x, and you give it a data type int, where do you think that go that information go to when you run the program? Straight in the registry. It goes into the registry as 1 and 0. So once you turn on the program, and you might ask the question, how does the computer know that is a program that is supposed to put in the registry? We're gonna look at that thing that is known as interrupt requests. We're gonna look at that next week. IRQs. Right? So different things, different component, or different parts of the computer have as what is known as priority. Let's say for instance, I am in my lab. A student is at the door. Miss Morris from next door is at the door, and the principal is at the door. And 3 person want to get my attention. Who would you think I would respond to first?
The one which has the
All right, let me
most
say it again.
important one.
The most important one,
The most
right?
important
The
one.
principal, right? The most important one, and that's how IRQ work. You understand? Usually, the keyboard has the highest priority on the computer.
Yeah.
Like for instance, the computer is running right now, and if I press something on the keyboard or the mouse, it gonna respond to it.
But that means I ask you now, or if you have higher priority over the most.
You understand? And we're gonna look at that in a little while. We're gonna look at let me see if I can find something about the IQ. I'm gonna see if I can find the IQs on this particular computer. All right. So it is device manager. Device manager. Let me open device manager and see something up is on this one. All right, let me open something and see let me see this, the keyboard and the mouse, the driver. All right, Java detail. Let me see details of this device description. Well, resource. I'm looking for resource. All right. So here's the IRQ right here. So interrupt request. So it tell you the memory range that the keyboard use, and it tell you the interrupt request for the keyboard is 0, 1. Let me look to see if or the most here. We want to know what the keyboard is 0, 1. And usually 0 is the highest. Is the highest. So I have 2 mouse right now. So I'm gonna look at these 2 mouse. I don't see any resource for the one there. All right, let me see. Yeah, about detail. Yeah, this doesn't give me any resource. Sometimes when you don't see any resource there, it has what is known as DMA, direct memory access. So you can go direct to the memory, bypassing everything else. Let me see. All right, what about the? I don't think that. Let me see processor. Mm, this I don't see no resource for that. Let me see the monitor. Um, print queue. Let me see printer. I don't have any printer installed on this. Mm. Usually, what you look for up here, so you look for resource. And they show you the different resource them, system devices. Mhm. Keyboard, imaging device, that camera. Let me see what no, that doesn't have any either. So so it seems as if the keyboard has priority over everything else. Let me see what is storage controllers. You don't see reserve for that. All right, we could just look at in general some IRQs and see the what priority each IRQ have. So we'll go back to the registry. But let's explain the priority first. IRQ priority. All right, IRQ. Um, computer IRQ. Um, priority. All right. Priority list. All right. Priority zero. Because the priority zero is what? Priority zero. Um, and our priority decrease with increasing interrupt number. Priority level zero is the highest priority level. You understand that, people? So when someone has of zero priority in our like principal, in our words, the principal have no time for waste. So the principal, if the principal and a student and Miss Morris come in the door, and the principal may go answer first. She don't have no time for waste. You understand? She have zero priority, so therefore she have the highest. And the student probably is the well, Miss
25.
Morris. Miss Morris,
No,
Miss Morris would be the lowest coming. She would probably realize. All right. And prior to level 255 is the lowest. In other words, like Miss Morris now, cross some would not pay no mind. 255. She have to rate the line. If a line them a line up, she have to rate the line 255 at the back. You understand? And I'll mainly attend to the student them needs more. So that's how the priority them stay. So therefore, when you're in a program, and the like for instance, you write a program, I have an application, a software, and you run it on the computer. The computer that program automatically has a priority in it, and it take over the screen, take over the RAM, and it start to put itself in the RAM. You understand? So um yes, so is it the interrupt request they use to signal what's supposed to run on the computer? All right. So let's just see if we can go back to the registry thing now. This one right here, so registry. So we can big it up. All right. So we're gonna look at the registry now to see what it is. Sorry about that. All right. So registry, the register is a quickly accessible location available to a computer central processing unit. Register are used to quickly accept, store, and transfer data. So it accept, it store, and it transfer data and instructions that are being used immediately by the CPU.
Okay.
Almost all computers load data from a larger memory into registers. Which large memory they're talking about right here, so? The RAM.
RAM.
Into registers, where it is used for arithmetic operations and is manipulated or tested by machine instructions.
Sure, RAM are not the hard drive.
No, the hard drive is so slow that anything at all that you see on the screen, that is
Yeah.
in the short-term memory in the RAM. It is loaded from the hard drive. It take a little part, it take piece of the program from the hard drive and run it and run it.
Yeah, so from hard
Understand me?
drive to RAM, from
Right,
RAM to register.
and from RAM to the register.
Okay. Okay.
Understand? And then
Yeah.
now it move from the registers now and go into the ALU. So the control unit control all of that now. You understand?
Yeah.
So if you write a program to calculate two numbers, say go to the register first, go to the RAM, then go to the register, come back for the hard drive because when you save it, when you save the program, you save it on the hard drive.
Yeah.
So
So the RAM,
when I run it now, when I run
the
it,
RAM
the
I
RAM.
use it.
Right. And now that bring me now to another important part now of all of this work now. So you're gonna write down this again now. Three stages, three cycle. Where it go through, where all of this go through. Fetch, decode, and execute.
What the
So
register?
the register and the CPU and the ALU. It go through a process known as fetch. It fetch the information, then it decode the information, and then after it decode it, then it execute it. So it is three stages. Ready now? So you're gonna write now, the three stages are a cycle of a CPU is to fetch the binary, fetch the binary data, fetch the binary data, and it can fetch it from the RAM. So it fetch. After it fetch it, it fetch some binary. When the CPU fetch binary, what do you think it do with the binary? It decode it, don't it?
Yeah, decode it
All right.
into
All
understand the
right.
language.
All right.
Program
Where
language.
what unit exactly in the CPU do the decoding?
Repeat.
What unit in the CPU does it do does it decoding?
Know that again.
The control unit.
Um,
Because the control unit have to say, all right, this coming, what am I gonna do with it? What should I do with
oh
it
yeah.
now? Where should I send it? You understand?
Yeah.
So after it decode it, then it execute it. It do something with it. It work on it. It process it. Right? So it is fetch, decode, execute. So look out for this on the test or an exam without question that I said or a question that the person said. That the cycle
After this.
of the CPU, the cycle of the CPU is fetch, decode,
Decode and
and
execute.
execute.
Yeah.
All right. So registers are used to quickly store, and it transfer data and instruction that are being used immediately by the CPU. All right. Almost all computers load data from a larger memory into registers, where it is used for arithmetic operation and is manipulated or tested by machine instructions. And the machine instructions are the ones and zeros. The ones and zeros, don't write this now, but the ones and zeros are a standard. And you have an American standard, some American company standard known as the ASCII. You heard about the ASCII term?
Yes, sir.
American Standard Code for Information Interchange. Because if they didn't have that that standard, then suppose I design a computer, and suppose the Americans design a computer, and the Japanese design another computer. If the Japanese then press A on their keyboard to send an email to America, why think would happen if America never have the same standard? To be chaos, don't it? It would interpret properly, don't it?
Yes, sir.
Yeah.
Right. So you have to have a standard. All right. So almost all computers load data from larger memory into registers, which is used for arithmetic operation and manipulated or tested by machine instructions. Manipulated data is then often stored back to main memory. Right. So when this is manipulated, and you're gonna see that in a little while in the drawing. And should I show you it now though? Yeah, you're gonna see it in a little while from the drawing. Where when the information is manipulated or executed, it go back to main memory, right? And sometimes memory ask you, and it's the best when it go back to the main memory, you store, you save it. If you don't want to save it, you can just discard it. Let's say for instance, you have a program and the program supposed to let me say we can go back to the famous calculator. Look at this for example. I know that is a program that used to write this calculator. It's a program that used to write this calculator. Don't it like C or C
Yes,
sharp or
sir.
whatever, don't it?
Yeah.
If I say 2 plus 2, right away, you know, that gonna registry, you know. You understand? I don't have to clear about this. 2 plus, let me clear this, clear this. 2 plus 2. And I press equal. You go right back to the after it execute, it fetch information, it decode it, then it execute it, and then it go back to the main memory. Right now, this gone back to the main memory. The result gone back to the main memory. It process it, and it send back the result back to the main memory. I can do several things with this now. I can save it or I can discard it. Don't it? When you say discard, I can throw it away. So that's what take place right here. So you say it manipulate the data, so the manipulated data is then often stored back to the memory. Because the manipulated data that I put in is what? 2 plus 2, don't it? Because
Yes,
2 is a data. 2 is not information. 2 is a data.
yes, sir.
And I say plus. In other words, I'm telling it to do something now. Add 2 to it. And then I say, give me the result. But where the result went back to? The result went go right back to memory. Don't it? It go right back to memory. Because remember now, you know, on the computer setup, you know, if you don't have any memory at all in the computer, you won't see anything on the screen. Don't it?
Yes, sir.
So it have to go back. It have to go back to the memory so that you can see it. So you see the information, all right? Processor registers are normally at the top of the memory hierarchy and provide the fastest way to access data. So the processor registers, in other words, the registers that are in the processor are the highest. All right. A register may hold an instruction. See here now, you're gonna hold an instruction, a storage address, or any kind of data, such as a bit, sequence, or individual characters. Right? So it all instruction. I'm gonna look at the different instruction. Can I have instruction register? It store address. Why store the address? Why would it need to store an address?
See where information are come from.
So you
Right.
see information there exactly to point to where the information is, or any kind of data, such as a bit sequence or individual characters. All right, you see right here, so computer circuit. Remember, we're looking at this a while.
Yeah.
We're just looking at this now with the clock. We send it out. See it? Computer circuits perform operation on the data displayed by the registry. Registry loads and display results of previous cycle on each upward clock edge. So on the clock edge, it's cycle and go through. Either whether I go left or I go right, it go in serially or it go in parallel, or it come out serial, come out parallel, or go in parallel, come out parallel. All right, but it does so on the clock edge. All right, where's the location of registers? See it right here, so in the CPU. And we have three things in the CPU. What we have in the CPU again now? You see them right here?
Yes, sir.
The
Register
registers,
ALU,
ALU, and the
controller.
control unit. All right, and everything is outside. RAM and ROM, the outside. Disk
Main,
drive, and the disk drive and the hard drive, them everything is the outside. Right, input, output. All right, input device, output device. Central processing unit, control unit, arithmetic logic unit, registers. And we have 1, 2, 3, 4, 5. We have more of these registers, right? And this is the memory unit out here, right? So the memory unit. So we have more than 5 registers, but they're mainly gonna explain all these 5 work. So so these 5 are in every microprocessor, but they have more.
Sir,
Depends on the microprocessor.
are
Yeah.
your notes there, sir?
Pardon me?
Are your notes there, sir?
No. I usually follow what some lecturers that you take do. Get you have to know where to get the appropriate notes from. You have to know where to get the information from. Why reinvent the wheel if it's there already?
Oh, yeah, man.
Understand?
That one they
Mhm.
figure give you them, that's what I ask.
Yeah, man. I go and go to them, man. I'm going to get
All
them.
right. All
I'm going
right.
to get it. All right. Types of registers now. There are various types of registers that are used for various purpose. Among some of the most widely used registers are MAR, which is a memory address register, and this speaks for itself. Memory address, right? So this deal with address bus, and the source the address in memory where you can find information. Accumulator, we're gonna look at the accumulator in a little while, but let me just say something about the accumulator. You ever try to write something on your phone or on the computer, and it seems as if it is predicting you, and it is writing something ahead of you.
Yes,
yes,
sir.
sir.
Right, that's the accumulator
Jump.
and do this.
Okay.
You understand? So especially if you do certain thing very often, it automatically gonna come up as I start right, it start come up again.
Yeah.
Because it's stored in the accumulator. All right. So data register is another register, and this register deals with data, right? And this is address register, which is different from the memory address register. You see, this strictly with address, right? Because you can't get address for just about anything at all. All right. I have program counter, and the purpose of the program counter is to um see the next information that is in memory, or that is in the register. All right. Memory data register is the same thing for the memory. I have index register. I have the buffer register. I'm looking detail in that now. See them right here.
No, off the
Basic computer
mark.
registers. These are basic computer registers. See them right here. And this is a list of registers right here. 1, 2, 3, 4, 5, 6, 7, 8. Last we could find about 9 of them, don't it? Right? Like for instance, DR, which is the data register, it all memories, memory operand. When I say it all memory operand, remember with the ALU, you have 2 operand, A and B,
Yes, sir.
right? So the data register put information in the operand, right?
Oh,
Oh, we
All
never
right.
did that last week, no?
Oh,
That's
you
all
never
right.
did it last week. Okay. I have AR, which is address register, right? And the address register all address for memory. In other words, it all the address for information that is in the memory. And the accumulator is the processor registry. Instruction registry, it all instruction for instruction code. Right? Like for instance, when you write out a piece of program, and that program convert into binary. By the way, when I write a program and it convert into binary, what software or which other program um sits between the high level language and the ones and zeros? What's the name of that program? Remember, I know your program as it now. What's the name of that program that sits between the high level memory that you write and the machine code? A compiler or an interpreter.
Jesus Christ. Yes, sir.
Remember?
Yes, sir. Yes,
It have to compile it into the machine language. I'd have to interpret it and split it up back as 1 and 0s. So the computer can understand. Because the only thing that the computer understand is 1 and 0. The computer don't understand A, B, C. It don't understand those things. Because A is a character, don't it? And how many bits make a character? 8 bits.
8.
8 bits of ones and zeros, and that's how the computer understand. So if you press A on the computer, you're gonna see ones and zeros, a combination of ones and zeros. It doesn't see the letter A. You understand now? Right. And
Yes,
then and then the control so when the controller unit see that, the controller say this is what this is now. This ones and zeros. Oh, American standard code. This is a coming. So let me just put that out. Try to do something. All right. So TR now temporary register. It holds temporary data. I have INPR input register. It all input character. All right. And output register all output character. All right. So anything that going to the computer, it hold it. Anything that coming out of the computer, it hold it as well. All right. We're gonna look at some of these videos if we have enough time today. And then look at our CPU work inside the CPU, inside microchip, but we can just go a little bit further. All right. Remember this? That's what we're looking at just now.
yes, sir.
All right. Registers are normally measured by the number of bits they can hold. For example, an 8-bit register or a 32-bit register. A register is simple, a collection of edge-triggered flip-flop. Edge-triggered is the clock I'm talking about. Each is capable to store 1 bit only. May have combinational gates that perform certain tasks. So flip-flop, so you see flip-flop come back again right here, so these are flip-flops, right? So flip-flops all binary information and gates control or and when new information transferred to the registry, right? So flip-flops are really registry. So what make up the registry is really flip-flops, right?
Yes,
And
sir.
what make up a flip-flop? What make up one flip-flop? Two or
Make
more
up-
gates, especially two
Yeah,
gates, don't it?
logic gate, sir. Yes, sir.
Two logic gates, right? And what make up one logic gate?
Transistor, sir.
Transistor. All right. How many transistor make one logic gate? One? I don't see it make one, you know. How many transistor make a logic gate? Two transistors. All right. 4-bit register. So 4D flip-flops, 4 inputs. It's right here. So the 4 input them 0, 1, 2, 3. Clock input. You must have a clock right here. So anyway, tell you see this little triangle thing right here. So this is a clock. And all of them synchronize. Right? All of them getting the same clock pulse. All right. I have clear input, right? And this is the clear right here. So all of them can clear. And remember when we were in the simulator a little while, what do we use for clear? What
Reset.
yeah.
They're not. They're
And
not
not.
clear.
Not.
That right. And which binary did you use? Which one did you use? 1 or 0?
1. 0.
0. We use a 0. All right. And it has outputs. All right. These are the outputs them right here. How does it work? Clock triggers the flip-flop at the rising edge of the pulse. See it? So at the right, remember we're looking at the rising edge and the falling edge. So the clock triggers the flip-flop at the rising edge of the pulse. Binary data and the input transfer to the flip-flops. The output sampled to obtain the information stored in the register. Clear, which is input if 0, our flip-flops are reset. See it right here, so if it is 0, our flip-flops are reset. Loading is transferring new information to the register. All right. Register with parallel load. Digital system of a master clock generator that supplies a continuous chain of clock pulse. In other words, when you have a computer, if you put a keyboard or a mouse, if you put a mouse, you see a little silver, a little shine thing. Let me see if I can find it and show you. Let me see if I can go online and show you how the clock look in the computer. All right.
Sir,
Yeah.
my phone battery probably soon dead. So may I ask you to post the video quickly?
Yes. All right, yeah, man, I'll do that. All right. So I'm gonna give you a crystal, CRYSTAL, crystal in crystal clock. Crystal clock in crystal clock in computer. All right, let me see it. Are you gonna see it? Are you gonna say, oh, that number talk? See it right here, sir? Is look at thing right here? See it?
Yes, sir.
See it here again right here?
Clock.
Is there another one? So when you look at the motherboard, I see this thing right here. So this is the clock. It's a crystal. It's a crystal. All right, they call it a crystal. Right? Not a crystal ball, though, you know. Right? There's a crystal. See there? See the crystal it to the timing 400 14 someone megahertz is a whole like this, right? And you get the marking. I tell them how much megahertz it is. So usually, if this is on the CPU, when they discussing the speed of the computer, this is what they are talking about. This one right here, so this one. So this clock right here, so is probably for something different, but this clock is for something different. But they have to synchronize. They have to have the same timing. It's like your heartbeat. Everything have to synchronize. Everything have to be the same. Like for instance, there's something wrong with you, and they want to check your pulse. If they can't check your neck, or they can't check your hand, or they can't check, so but it's the same beating, same pulse. You understand?
Yes, sir.
So if you have a keyboard, a crystal have to be in the keyboard as well. If you have a video card, I want to put it on to the computer. That video card come with a crystal. It
Or
come with a clock.
external devices. Have
Yeah,
them
external device. Yes.
crystal.
So once you plug it onto the computer, I synchronize with it. I start to move with it. So everything moves together as one.
Cool.
All right. So we can just go back to this again. Where is it? All right. So so it's this is a system of a master clock generator that supplies a continuous chain of clock pulse. And everything else that you put onto to the computer, you plug onto the computer, it has to follow the master clock. Right?
Or
So
have to have the same rhythm.
it has to have the same rhythm. All right. So pulses are applied to all flip-flops and registers in the system. If all the bits of the register are loaded simultaneously with a command clock pulse, we say that the loading is done in parallel. All right. A separate control signal must be used to decide which register operation will execute at each clock pulse. Right? And they say, can we use gates and the clock clock inputs? All right. We can look at that at another time. In other words, what you're saying right here is a separate control signal must be used to decide which register operation will execute at each clock pulse. Everybody understand what this is saying right here, sir? Different timing on the clock operate different register to send different information. You understand? You understand that?
The last part there says the separate control signal.
All right. A separate control signal is used and must be used to decide which register operation will execute at each clock pulse. So if you have a clock and the clock is pulsing a certain way, let's say for instance, at the first clock pulse, say the CPU is supposed to work at every 10, every 10 rising edge is the CPU. Every 2 rising edge is the keyboard. You understand?
Yes, sir.
And so forth. Every 3 rising edge might be the most, and different things like that. Right?
Right.
All right. Register with parallel load. Inserting gates into a clock path means that logic is performed with clock pulse. The insertion of logic gates produce uneven propagation or delays. In other words, delayed. You understand? Between the master clock and the input, a flip-flop. So you might have different operation going on. In other words, you can interrupt the